For problem number 3, it says that a passenger at an airport pulls a rolling suitcase by its handle and uses a force of 10 newtons. So I'm going to stop right there. So we have a rolling suitcase with a handle, and he uses a force of 10 newtons. And the angle to the horizon, or theta, is 25 degrees. What is the work done if the passenger walks 200 meters? So the first thing I did is I drew a picture. So you have a rolling suitcase, you pull the handle up, and you kind of pull it at an angle. In this case, they say the angle is 25 degrees above the horizontal. And then the final question, and so I labeled it as I read it. In fact, I'll read it one more time all the way through. A passenger at an airport pulls a rolling suitcase by its handle. If a force of 10 newtons is used, the handle will make an angle of 25 degrees to the horizontal. What is the work done by the pulling force if the passenger walks 200 meters? Well, this one's kind of easy. It's just force is equal, or not force, work is what we're looking for, and that's equal to the magnitude of the force times cosine of the angle theta times the distance. So 10 newtons is the force. Cosine of 25 times the displacement, which is 200 meters. And what I want you guys to understand is we have this, if I were to draw a free body diagram, I have 10 newtons of force being applied at an angle. What I'm really trying to calculate is the component, the horizontal component of the force. So remember that this 10 newtons is a resultant vector of a horizontal component and a vertical component. This horizontal component, this right here, is really the force times cosine of the angle theta, which is right here. Does that make sense? And if I wanted to, although you're not required to or asked to, the horizontal component is the force times sine of theta. So that's why we have that cosine of theta plugged in there. We're just separating the horizontal component of the force, because remember, the work done is the force that's parallel to the displacement. Does that make sense? And since the 200 meters is in the horizontal direction almost always, at least that's how it's rigged up in your textbook, it's going to be cosine of whatever the angle above the horizon is. So when you plug all that in your calculator, you should get work is equal to 1.8 times 10 to the 3 joules, I think is what it'll work out to.
I got 1812.6155.
Yeah, they are using significant figures.